Welcome, athletes far and wide, to another edition of Hacking the Star. I tried to go get my friend SpongeBob, because I don't mind it when he interrupts my lessons. Unfortunately, he lives at the bottom of the sea, and I could not hold my breath that long. But after a trip to the sea, I did bring back my friend Surfer Dave, hey, brah, who said he would help us out with today's lesson. Give me a high... You don't have five, but your hand's kind of like a C shape, so give me a high C. A high C. Oh, that sounds radically refreshing, bruh. No, I meant like with your, I don't actually have a high C with me. That's totally wax, dude. And I don't mean this board wax that I'm using. I mean, how could you offer somebody a drink and get them all excited for refreshment and then like totally leave them hanging, bruh? You're right. That was mean of me, and unintentionally though. Well, if you just hang out here for a second, Surfer Dave, I'll go get you that high C. I apologize for misleading you like that. Hang on. One hour later. What is this? That did not take me an hour. Who put that there? Anyway, look, here's a high C for you, huh? Gnarly. All right, I'm going to stick that there. We're going to start some math. You ready? Like, totally ready. All right, well, you want to come over here and read this for me? Bro, I've got like way too much work to do to be able to read. You got to read it to me while I finish waxing my surfboard. Yeah, you know, my students kind of make me read all the questions for them too, and I don't think any of them even own surfboards. Well, yeah, here, you hang out here with your high C, you just answer my questions, and we'll use some pretty ocean colors. Ocean blue, seafoam green. I have no idea if those are those colors. Anyway, it says, what is the value of the expression 6 3/4 times negative 11.5? And so I've got a fraction. Actually, it's a mixed number. Do you know what a mixed number is, Surfer Dave? Bruh, I've heard that word, but I know like zippy zap about it. Okay, well, a mixed number, it's got a whole number and a fraction together. It's actually secretly a hidden addition problem. It means 6 whole and, or plus, 3/4. And so I've got that mixed number that is kind of a fraction, kind of a whole number, times a decimal number. And then I look at my answer choices. My answer choices are all fractions. So I got two options. I can either turn this all into decimals, do all my decimal work, and then convert my answer back into a fraction, or I can use fractions the whole way through. So I want to be able to do both. And because I want y'all to be able to do both, I'm going to show you both. But on this particular question, if it showed up on a test, I would not waste any time with the fraction method, because if I compare these 4 answers, bro, that's like a righteous wave you just drew there. Thank you, Surfer Dave. I think you can come back for next week's video too. You know what? If you're not busy this afternoon, we'll just make 2 of them today. Radical, dude. Anyway, if I look at my answer choices, I don't even need to know what the decimal part of the answer is and turn it into a fraction. If I get positive 77 and some decimal, it's got to be F. If I get positive 69 and some decimal, it's got to be G. Negative 77 and some decimal, it's got to be H. Negative 69 and some decimal, it's got to be J. So while I would love to tell you, you should keep it as a fraction because your answers are fractions, in this case, quite frankly, you don't need to, and it would be kind of a pain if you don't feel comfortable with fractions. So if I can move your high C over to this side of the paper for a minute, Surfer Dave. Oh, not without me. Come here, you delicious box. All right. I can take 6 3/4, and I'm going to turn that into a decimal number, and then I'll just have a decimal times a decimal. Now, again, I'm going to show you how to do this with fractions too, but the way you should do this on a test, because the answers lend themselves to being able to pick it out without the reconversion, is to go ahead and switch it into decimals, which most people feel more comfortable with. So if you've got 3/4 memorized, good for you. That's what you should do. If not, you can literally do 3 divided by, okay, draw the building, leaving the building, saying by, so 3 by 4, and I can just divide it out. Now, 4 can't go into 3, but what if it were $3? Well, then I know there'd be a decimal place and 2 zeros afterwards, and any whole number, I can write the decimal place and as many zeros afterwards as I need. You mean like literally as many? Yeah, like I could write 1,000 zeros if I wanted. What about like a quadrillion? Well, that would have to be a real number, but if it were, yes, I could write a quadrillion zeros. Anyway, 4 can't go into 3. If I have 3 cookies and 4 people I'm splitting them with, there's no happiness there. So no, not doing that. I put the decimal up top to line it up with the decimal below, but once it's there, I ignore it in all the places. I pretend it's not even there, and I say, well, what if I had the number 30? How many times could 4 go into 30? And I know, because I know my 4 times tables, it's going to be 7. 7 times 4 is 28. If I'd try to do 8 times 4, that would be 32. That's too big. But 7 times 4 is perfect. I subtract 30. Again, I get to ignore this decimal now that I've moved it up top. 30 minus 28 is 2. And it's not 2 by itself because there's another 0 waiting to hang out with it. I know a few zeros I like to hang out with. They're cool, but they also need jobs. Okay. Thanks for that, server Dave. Anyway, 4 goes into 20 exactly 5 times. And if I'm not sure, I can go ahead and multiply 5 times 4 is 20, write it down, subtract, prove it's 0. But I know my 4's timetable well enough to know, boom, I'm done. So don't forget, this was an addition problem. I had 6 plus 3/4. And now I know how to write 3/4 as a decimal. So 6 and 3/4 is the decimal number 6.75. And I'm going to write the 11.5 underneath. Now, this wasn't just because I forgot what I was doing and I accidentally put the small number on top. I was thinking ahead to how this is going to make my life easier. If I do 11.5 times 6.75, I have to do 5 times 5, 5 times 1, 5 times 1, 7 times 5, 7 times 1, 7 times 1, 6 times 5, 6 times 1, 6 times 1, and I have to do that for these 3 places. In other words, I have to do 9 different multiplication facts. But here, when I put those double digits on the bottom, I'm going to be able to reuse 1 times 6.75 up top. Okay? So for just a minute, I'm going to ignore these decimal places. Put these in little bubbles and say, for now, they're not there. We're going to deal with those at the very end. I want to go ahead and multiply what looks like now 675 times 115. 5 times 5 is 25, so I put the 5 here. 20 up top, 25. 5 times 7 is 35, plus 2 is 37. 37 might be an easier way to write it. I typically write the ones place and then the tens place, but if you need to really remind yourself, okay, this is 37, go ahead and put the 30 up first and then the 7 next. So 5 times 5 we did, 5 times 7 with that we did, and then 5 times 6 is 30 plus 3. Well, there's no place left to carry it, so now that 33 can just come down here. And I took care of my 5 spot, so I am done dealing with that spot there. And I go to my 1 spot. Well, 1 times anything in the universe is itself, so I don't need to do this 1 digit at a time anymore. I can say 1 times 675 is 675. Now I'm done with this 1. Done with that spot. And I can go, and again, I don't have to re-multiply, even though it's a super easy multiplication problem. I can literally just copy 675 there. I've got to add this all up, and after I add it all up, don't forget I've got these decimals I got to deal with, and there's one more thing we got to deal with at the end that I hope you've noticed already. If not, I'll surprise you with it. Down here, when I add these up, 5 times nothing is 5. 7 plus 5 is 12, plus nothing else is still 12. Carry that 1. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. And I did that jump because the order doesn't matter, and I have an easier time adding 5s in my head than 7s. I could have also done 7 plus 3 first, because that's an easy add to 10 addition fact, and then I'd do 10 plus 1 plus 5, which I know is 6. So remember, as you're adding these, you don't have to go top to bottom. As long as you can keep track of which ones you've added and which ones you haven't, make it easy for yourself. Here, 3 plus 1 plus 6 is 10. I know that 10 fact pretty well. And then 7 makes 17. You might also have picked out, oh, 7 plus 3 is 10. And then with 6 and 1, again, that's also 17. There's no way you could do the math right and get the wrong answer. And so, if this weren't a multiple choice test, it would really matter how to explain this decimal part. But look at my options. It's got to be a 2-digit number. So even before I start, I know the decimal is going to go right here. But because sometimes you don't have multiple choice questions, let me show you why that is. If I look at these decimals on top and count all the numbers to the right of the decimals, there's 1, 2 from that first line, and a third one from this. So I count them all together for the whole top part of the problem. 1, 2, 3. And that number has to exactly match the digits behind the decimal in my bottom. So I would go 1, 2, 3. That explains the 77. And if you're about to jump over and pick F, don't. Because what I didn't write in the problem was the negative sign. Why didn't I write the negative sign? Well, for me, I wanted to write the multiplication sign, and I didn't want to get distracted and think, wait, am I multiplying or subtracting? So I saved that to the end. That's a dangerous thing to do. And so what you might want to do is before you start, take a look at what you have up top. I have something positive times something negative. And if you know your rules, you know a positive times a negative will always be a negative. The only way I can multiply negative numbers and end up with a positive is if they both match. A negative times a negative, that's a match. So that's a positive thing. Otherwise, anything times a negative is going to be negative, and I would have right off the bat gotten rid of F and G, done my multiplication, and not have to worry about carrying that sign. You're also welcome to write the sign, carry it through to the end. You figure out what way works best for you, which way you can do the least amount of math mistakes, and go for it. So again, I don't have to turn this back into a fraction because the test isn't making me. I know the only thing that starts with negative 77 is H, and that's got to be my answer. I love it. That's like almost as cool as surfing. Thank you, Surfer Dave. Now, what is as cool as surfing is turning this into a fraction, and really, I'd have to turn those both into improper fractions. How do you feel about improper fractions? Again, bro, I know that word, but I know like zippy zap about it. All right, well, we could save this for another time, but let me do it real quick for you. And then if you have questions, or if any of y'all have questions, just send me a message in the comments and let me know what your questions are. So I'm going to start with 6 3/4 times 11 and a 0.5. And I'm going to put that negative sign out in the front so I don't have to deal with it inside. I know it can go there because at the end, any negative times any positive will give me a negative answer. So 6 3/4 has got to be an improper fraction. The crazy thing about multiplying is that it's easier to do once you set it up, but it's harder to set up than if I'm adding. I cannot ever multiply a mixed number. I just can't. And so I have to turn this into an improper fraction. For those of you who live in Texas, you may know that the bottom left part of your state is kind of slanty, and the top part of your state has a little boxy top. And so you can remember the Texas method if you want. It's the bottom number, the denominator of the fraction, times the whole number, plus the numerator, the top number. The only thing is, I need to remember what I'm talking about. I have 6 whole and 3/4. So what parts am I talking about? I'm talking about the fourths. And so even before I do any of this Texas two-step, get it? Because there's 2 steps to it. And no, you kids don't dance. All right, never mind. Even before I do any of those Texas 2 steps, I want to make sure I remember at the end, it's still going to be fourths on the bottom. So 4 times 6 is 24. 24 plus 3 is 27. Boom. 6 3/4 is the same thing as 27/4. 11.5 needs to be an improper fraction, but it would have had to be a fraction in the first place. Well, again, thankfully, I know 0.5 is the same as 1/2. But what if I didn't? Well, don't forget, I could read this as 11 and 5/10. Oh, 5/10 could look like this, but it could also just as easily look like that. And so I say, all right, I'm going to have 11 and 5/10, and I'm going to use my Texas two-step and turn that into an improper fraction. Again, because for some reason, you just can't multiply mixed numbers. So 10 times 11 is 110, plus 5 is 115. And what was I talking about? I had 5/10. The pieces I'm talking about are still tenths, and there I go. I'm now ready to multiply this. Top times top, bottom times bottom. And so I'm going to have a big number on top divided by 40. Let's put a little side panel here for my big number. 115 times. Would there be any point to write this below? No way. Don't forget, putting the double ones on bottom not only gives you an easy multiplication thing on the bottom, but it gives you a double where you don't have to remultiply, you just repeat the fact. So I'm going to write it out like this. 5 times 7 is 35, carry the 3. 5 times 2 is 10, plus 3 is 13. Done with my 5's place, done with this place. 1 times 27 is 27. I'm done with that 1's place. And again, 27. Add these all up, and I have 5. 10, carry the 1. 11, carry the 1. I've got 3,105 divided by 40. Kind of a pain. And so I don't mind showing you this way because it was by far the best way to tackle this problem. If you ever need to, we'll keep going through these steps. 3105 divided by 40. Okay, by means put it inside the building. Let me switch colors because my math is running into itself here. By 40. 3,105 divided by 40. And so 40 can't go into 3. If I have 3 cookies and 40 kids, there's no way I'm splitting that up without absolute disaster. 31 cookies with 40 kids? Still not going to happen. But 310 cookies with 40 kids, that's manageable. I'm going to pick right here a 7. Because what I'm seeing here is if I ignore the 0, I'm really trying to figure out how many times 4 can go into 31. And 8 times 4 is 32, so 7's got to be it. 7 times 40 is 280. I subtract that. I get, borrow from here, 30. Bring down the 5. Just waiting to hang out. 5, like a hanging 5. Sure. Yeah, that'll work. Whatever you want, Surfer Dave. And I've got 4 into 305, which again would be 7. 7 times 40 is again 280. Try to wrap my subtraction around here. That's going to be a 5 and a 2. And so I've got 77, and I want to go to remainders. A lot of times, people are used to knowing you could put a decimal and keep dividing, and they just jump for it. But remember, I turned this out of a decimal into a fraction because I wanted a fraction. So don't worry about continuing to divide. Keep that 25 as your remainder. So let's hop on over here. 77 whole and remainder 25 over 40. Where did that come from? Well, don't forget, that's where it started. The reason I chose to divide by 40 is because that was the bottom of my fraction in the first place. This doesn't match my choice here that says 5/8 because it turns out 5/10 wasn't as simple as you can get. Either way, you don't have to worry about that as long as you know how to simplify. If you notice they both end in a 5 or 0, they can both be divided by 5. So I divide top and bottom by 5. 5 there, 5 there. And I get 77 and 5/8. The negative sign should be there all along. And boom, it's H either way. So this one here is a multiplication problem. You know for sure the answer is going to have a negative because a positive times a negative is a negative. I go ahead and I do that, and I get over here to the side 2.2 times 9. Negative sign is going to be there. 18 here, carry the 1. 18 plus 1 is 19. Is this 1.98? 19.8? 198? We'll check up top. When I leave the decimal, I have 1 spot to the right. So by the end, I need 1 spot to the right. This is going to be negative 19.8. How you feeling, Surfer Dave? I'm totally ready to hit the waves, man. I meant, how are you feeling about the math? Oh, it's like a lot of numbers. If those numbers were oceans, I would be surfing forever. I guess that's a good way to think about it. Here, let me move your juice box over here. And we'll move on to Stephanie's problem. She's got 3 3/4 bags of soil to put in her garden. Each bag of soil will cover 125.3 feet squared. How many square feet will Stephanie be able to cover if she uses all these bags of soil? And when I look at my answer choices, I have only decimal answers. So there's no way I should keep this as a fraction. I'm not even going to show you that method on this problem. I want to jump straight to the decimals. 3 3/4. Now, I know earlier, and I had it memorized, so this is a great one to memorize because it's so common, that 3/4 is the same as 0.75. So I have 125.3 times 3.75. Now, how did I know that was going to be multiplication? If I had only had 3 bags, and each bag only covered 100 feet squared, it's a lot easier to think about. And as a very good test-taking strategy, if you're not sure how to solve a problem, or you are sure you tried it, your answer didn't match, or you have time at the end of the test to go back and check the exact same question with easier numbers and see if your answer still makes sense. So if she had 3 bags of soil and each bag would cover 100 feet squared, I know right away that's going to be 300 feet squared because it's 300 because 3 bags, 100 feet each. So it's like, okay, well, here's a bag, here's a bag, here's a bag. They can cover 100 feet squared, 100 feet squared, 100 feet squared. I could add those up, but really if I'm adding the same thing over and over again, really, I'm just going to multiply. And so if you can work that example of a simpler group of numbers with the same exact question, then you'll feel like you're on the right track for sure. My actual multiplication here, 5 times 3 is 15, carry the 1. 5 times 5 is 25, plus the 1, carry the 20. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is 6. Whew, done with that one. 7 times 3 is 21. Write the 20 over the top of the 1 so I don't get distracted by the 1. And put the 1 down. 7 times 5 is 35, 36, 37. Make this a 3, make this a 7. 7 times 2 is 14, plus 3 is 17. Boom, boom. 7 times 1 plus 1. Got an 8 there. And whew, finally done with that 7's place. So I can move on to the 3. 3 times 3 is 9. 3 times 5 is 15. Whoop, carry that 1. 3 times 2 plus 1, that's a 7. Nothing to carry. 3 times 1 plus 0, because I carried nothing. And there I have it. Add all these up, and I get 5, 7, 18, 19? Yep. 16 and 4. Where's this decimal place going to go? To the right of the decimals on top, I have 1, 2, 3. So I need 1, 2, 3, 496.85. That's not a 96. That's a 69. And I'm done. Last one here. This is an example where you should just use fractions. So I had a fraction choice, a definitely decimal again. Here it says the diameter of the handle of a softball bat is 1 3/4 inches. What is the length in inches of the diameter of 8 of these bats? Well, instead of adding these up 8 in a row, no way. I know I can just multiply. 1 3/4 times 8. Same problem though, I can never multiply a mixed number. So I use my TEKS 2-step, boom, 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 boom. 4 times 1 plus 3 is 7. And what was I talking about? Oh, the pieces have always been fourths, so I'm still talking about fourths. When I multiply, I want to be able to say top times top and bottom times bottom. So I'm going to rewrite 8 as a fraction. And here's a cool thing. If I have 8 whole, that's got the number 1 on bottom. Just like if I have 1/2. I don't call this 1/2, even though there's a 2 on the bottom. It's got a special name, half. 1/3 isn't 1/3. It's got a special name, thirds. A 1 on the bottom has a special name. It's not 8/1, it's 8 whole. And once I know that, it makes this so much easier because I do top times top, bottom times bottom. And this becomes now just a division problem. I've got 56 divided by 4. 56 divided by 4. 4 can go into 5 one time. 1 times 4 is 4. Be 1 left over. Bring down that 6 to hang out. 4 goes in exactly that many times, and boom. The answer is D. Well, ocean markers, you've done me proud. Surfer Dave, yeah. You have any questions? I do have like one very important question, bruh. All right, what's your very important question? Can you open this high C for me? I can't reach the straw. Do you have any math questions, Surfer Dave? No, dude, I got the math. I just need the drink. All right, I will open the drink for you. Mathletes, y'all find some math problems out there and go ahead and test the skill on your own.